Hey everyone, welcome to episode 27 of LDA's weekly Wednesday webinars. We feel really lucky to be here talking to you. My name is Jarred Bussell and this is my colleague Jordan O'Sullivan. I think he should appear below me on the screen if that worked out properly. I think underneath
above
me. It's important that we get that order right. Jordan and I have been working together for many years, close to a decade actually. We started out in the mining town far northwest Australia called South Headland. That's where we cut our teeth. And that's also where we met Dr. Lorraine Hammond, who's been our kind of guide and mentor for many, many years, kind of points in the right direction of effective practice. So we started off in South Headland, up in the mining town, and then we came down, we had some success up there teaching, and then we came down to Perth metro area in the city. And that's where that's where the Dawson Park story starts. Some of you might have even visited Dawson Park to see some teaching instruction there with Dr. Hammond or with Fogarty Advance or something like that. Dawson Park's a fantastic story that we're really proud of, and it's just a combination of teachers who really, really want to achieve some positive change with their students, who believe in their students, being connected with research, evidence-based practice, things that actually work. And that started a beautiful story over at Dawson Park that continues to this day, where kids are achieving above what's expected of them. And this is having a big impact on the community there. And so we're really proud of that. That's our little contribution to the system. Today, we're going to talk about something that's part of that, which is explicit teaching in maths. So hopefully we're going to build on the good work that's already come through in the previous LDA Wednesday webinars. And hopefully we can impart something that we've learned through our experience. So I'll hand you over to Jordan.
Sorry, mate. Can I just add? Apologies that we've had to pre-record this session. We did aim to do it live on Wednesday, but Jarred has some other commitments at that time. Seems to have got a reputation for letting the team down, But, it's probably a good thing too that we're not live, because that was actually take number 35 or something. I actually lost count from Jarred doing his intro. So
why are you sharing all this information?
All right, let's get into it. So we've got a couple of goals or a couple of topics for today's session. The first thing that we're going to spend some time talking about is interleaved practice. So we're going to take a little bit of a deeper dive into interleaving. Talk about how that relates to problem solving. And to do that, we're actually going to build on some ideas that David McCunis covered in his really good WWW session last year. So probably if you haven't seen that, you really should. Not because it's a precursor for some of the ideas that we're going to talk about here, but because it's actually a really good video in its own right. So please do pop back and view that before you give ours a viewing. A lot of the ideas will make more sense if you give that a watch first. So we'll talk about interleaving. We'll also talk a little bit about daily review. And also weekly and monthly review, because we know that daily review's been a word that's been used more and more frequently in the last couple of years, and David debriefs that really good in his video. But that's only one of Rosenshine principle, and we know that one of the other principles is weekly and monthly review. So we'll look at how we've interpreted what Rosenshine says about weekly and monthly review, and look at some practical stuff that's been happening at Dawson Park Primary School over the last couple of years. And then after that, we'll also look at some of the literature on worked examples. And Ollie Lavell's got a really good chapter in his new book, Cognitive Load Theory in Action. But what we'll do is we'll try and apply those findings in terms of worked example to that common structure of explicit lessons of I do, we do, you do, and talk about how we've incorporated worked examples into that structure in the past, and also how we do it currently at Dawson Park. So let's get stuck into it. So we picked these two topics because if we look at Rosenshine's principles, obviously number 1 is daily review, number 10 is weekly and monthly review there. So that's our first topic. But then we picked the second topic because that we do of an explicit lesson is so important in all learning areas, and that includes mathematics, because most of these other principles are features of that part of an explicit lesson. So the we do is critical, and we'll talk about worked examples occurring in the we do. Let's firstly look at what Rosenshine actually says. So let's look at the quotes from his paper in terms of daily review. So the first point that he makes is that he observed effective teachers running a 5 to 8 minute review of previously covered material. So we know that that seems like a brief amount of time, and we know that lots of teachers who have been implementing daily reviews have been running them for a lot longer than that. And that also aligns with Rosenshine's principles, because he makes the point several times: the more practice you do, the better the performance of your students. So it's absolutely, I think, a good idea to run longer than 5 to 8 minute reviews if you have that time available. So within that 5 to 8 minutes, what Rosenshine says that he observed effective teachers do is firstly review and practice facts and skills that were needed for recall to become automatic. So another way, I guess a synonym for that is basic facts. We know that every learning area has a set of facts and skills that are really critical for performance in that learning area. So that's one thing that he observed teachers doing in a daily review. The other thing he says that he observed is effective teachers reviewing knowledge and concepts that are relevant or precursor to the lesson that's about to follow. So I guess it depends how you're structuring your explicit teaching as to whether you do that or not. We know that lots of explicit lesson structures have that prior knowledge built into the body or the introduction of a lesson. Sometimes it's called activating prior knowledge. So I guess if you're incorporating that into your lesson structure, you might not necessarily do that in a daily review, and instead your daily review focus on basic facts and skills for your learning area. So if we just summarize those points, we conceive daily review based on what Rosenshine says to be about reviewing basic facts and skills in your learning area, and possibly also facts and skills that are related to or precursor to the lesson that follows. So that's daily review. Let's have a look now what he says about weekly and monthly review. So I'll let you have a quick read of that. I won't read it to you.
Maybe I should read it to them.
I don't want to hear you. Okay, so we've highlighted that point there: discussion and application activities. So that's not something that Rosenshine says in relation to daily review. Another important point here, have a read of that. So we think that that point of skilled, successful performers who could apply their knowledge and skills in new areas is an important one, because really that's talking about transference, and we know that transference is mostly about problem solving. So what we have interpreted Rosenshine's principles of daily review and weekly and monthly review to mean is that daily review is about the basic facts and skills, whereas weekly and monthly review is more of a focus on application and problem solving. Now, we know that there's probably going to be some overlap, but we think it's important to make this distinction. We'll go into it a little bit more detail as we come through here. Okay, so that's our first takeaway. We're going to build 4 or 5 takeaways through this little first half of our presentation. So the first takeaway being daily review, basic facts and skills; weekly and monthly review, application and problem solving, the focus of those respectively. Okay, so in David's video, he talks quite well about interleaving and how that occurs in the maths daily reviews that they're running at Bentley West. So a really simple basic definition of interleaving, and we'll extend on this a little bit further later, but a basic definition is that interleaving is mixing it up or varying the order of items or topics. So that's a second important takeaway, is that basic definition. Interleaving involves varying the order of items or topics. Now, we also think that it's important to make a distinction between, or to think a little bit more about what we're actually interleaving when we're reviewing or providing practice of material. And we think that you can provide interleaved practice of basic facts and skills, but you can also provide interleaved practice of problem solving. And we'll talk a little bit more, I know I'm saying this a lot, but we'll talk a little bit more about why we think that distinction is important in a second. Okay, so let's talk about interleaving of basic facts first. So this is something that teachers often do with their students, and I've often done in the past, and it is important practice. So this is having students chant their times tables in order, in sequence, and then maybe we also take that a step further and take the answers away and have them chant their times tables in order, forwards or backwards. This is important practice at some point for students, but it creates an issue too, because if we think about what students are actually having to retrieve from their long-term memories when they're doing this type of activity, it isn't the answer to each individual fact. When we have them chant in order, what they're actually retrieving is that skip counting sequence. So when, for example, they get to 5 times 5, they're not actually thinking, okay, what's 5 times 5, and trying to retrieve that from their memory. They're just retrieving what comes next in the skip counting sequence. With 4 times 5 is 20, that was previously, so this answer must be 25. So the way we get around that is to create what we call desirable difficulties. And one way to create desirable difficulties of this basic fact recall would be to interleave or mix up the order of those problems, so that students can't fall back on the sequence. They're actually having to think for each individual fact here what the answer is. So sorry, we do have another takeaway, but we'll get to that. So this interleaving or mixing up of basic facts is an important thing for us to do. And what we know is this recite, recall, apply structure that David outlined in his video, and that you'd be familiar with if you're at a school that uses John Fleming's effective teaching model, for example, actually allows us to do that interleaving of basic facts. So if we just make reference to David's video here, and hopefully, again, you've gone back and looked at it, the structure of a daily review is recite, recall, apply, and recite is usually chanting together in unison the information from the screen. So all the answers are there. Whereas recall is about students trying to remember that information. So David spoke about orally or asking students questions that they respond to in unison, but again, mixing up those facts in doing that, so in a random order. So that there in the recall is interleaving basic facts. And then he talked also about how the application can be students practicing those, practicing retrieval of those facts independently. And again, we can see that those facts are interleaved. So that is our next takeaway, that we should aim to interleave basic facts in a daily review at some point, and that recite, recall, apply that David spoke about in his video allows us to do this interleaving. Let's take a little deeper dive into recite, recall, apply though, because there's some other important points to make. So David spoke about in his video how the apply in recite, recall, apply can involve students independently practicing basic facts. But if you think about it, application could also involve solving problems for which the basic facts are precursor. So let's have a little bit of a look at that. So this is something that I often used to do in my practice. So as an example, we go through our times tables, we chant them in order, and then maybe I do that thing where I quick fire randomly ask them questions that they respond to as a recall, and then I go, okay, you solve this problem, you solve this worded problem here. But what I realized is that there's an issue that exists here that we need to be aware of. And to be aware of that, we probably need to have a little bit of a deeper dive into interleaving than that basic definition that we spoke about earlier. So the first issue is that actually all of the, most of the, possibly all of the literature into the effects of interleaving, and the studies that have found positive effects of interleaving have been about problem solving, not about the recall of basic facts. So we talk about interleaving a lot, but the evidence that exists is talking about problem solving. And we know that because if we look at some more definitions from the literature, we see that problem solving is the common thread through those definitions. So this mentions problems several times, strategies, and solving, and even lists out some problems here. So interleaving in this definition involves mixing up the order of the topics that or the strategies that are needed for problem solving. So when we do this, what happens is students are required to not only use a strategy to solve each problem, but they also need to choose which strategy they need to use. And it's quite logical that that's an important element of problem solving. Actually deciding upon what strategy is required is an important part of problem solving. So I want you to keep that in mind, that interleaving should require, by definition, students to choose and use a strategy for each problem. Let's take a little bit deeper look at the evidence. So sometimes interleave practice and spaced practice gets confounded a little bit, and this is because if you provide interleaved practice by its definition, you are automatically providing spaced practice, but the reverse is not necessarily true. So let's look at this. Remembering that interleaving requires students to choose and use a strategy for each problem. This one here is blocked practice. So we can see that topic A, nine problems of topic A are covered on day 1, 9 problems of topic B on day 2, 9 problems of topic C on day 3. I think, you know, most people are aware that that is an ineffective way to provide practice for students. So what we often do, and what occurs probably in daily review if we think about it, is this spaced mini blocked practice. So this is spaced practice, and you can see that because each topic is spread over 3 days, but it's not actually interleaved practice because students are not required to choose and use a strategy for each problem. So this would be an example of interleaved practice. For each problem, they need to think, okay, what is the strategy I need to use, and also apply that strategy as well. Whereas in this spaced mini practice, they're probably only having to do that for the first question in each little mini block of 3 here. And then, you know, the strategy is being given away by the problems that exist prior. So keep that in mind. Interleave practice involves choosing and using a strategy for each problem. And we're going to talk a little bit more about how to maximize the impact of interleaving in terms of problem solving too. But come back to this point. Think back to my example before. Remember that the apply in a recite, recall, apply can be about independent practice, or it can be about solving problems. And I had this example before that we're going through our times tables and then I'm giving them a worded problem to solve. But the issue with this is that students do not have to choose the strategy for this worded problem. So this was a mistake that I'd so commonly made. And what I realized after a while was that students weren't even reading the problem. They just were going, yeah, okay, 5 times tables, I see 5 there, I see 8 there. They multiply them, they get 40, bang. They weren't even reading the problem. So they're not in solving that, considering the structure of the problem. They're not actually improving their ability to problem solve. And that is because this recite, recall, apply can inhibit the effects of interleaving. So probably what we need to do, if we do want to have students solve some problems, we probably want to make use of the fact that we're telling them the strategy in advance in the recite and the recall. And we can do that by having them apply their knowledge to a new problem or a structure that they haven't seen before. So this one, for example, maybe they haven't seen this 2-part style problem for multiplication. And we can guide students and possibly even lead a discussion about why does this involve our 5 times tables? How can we apply our 5 times tables to this problem? And we might go into the fact that we can multiply 5 by 9 and 5 by 6 and add those together, or that we can add 9 and 6 and then multiply it by 5. And so by doing this, by making use of the fact that we have told them the strategy that they require, we're actually value adding to their ability to problem solve. So if we do want to do problem solving in our daily review, we probably want to be extending them a little bit further. But I guess the issue with that is that takes time to lead those discussions. So it's probably suggesting that maybe daily review is not the best place to develop problem solving skill for students. Possibly another structure that you could implement if you do want to do some problem solving with students, and maybe this is a quicker one to do. If we structure our questions like this, where it's multiple choice, we're directing them to first identify which problem requires their 5 times tables before they actually go and solve it. And what this does that my other example doesn't do is it requires students to consider the deep structure of the problem. They can't just see those numbers and multiply them. They actually have to think about the problems themselves. So that could be a possible another easy way to structure your questions that requires a bit more of students and provides what we call desirable difficulties. Another example is something that I used to do a lot, mistakes of the past. So an area example, we're reciting what the definition of area is, the formula for area, and then we're having students recall that information from hopefully their long-term memories. And then, I used to give them a set of problems like this. And again, all they do is they see 4 and 5, they multiply 8 and 2, multiply them 3 and 1.5, multiply them. So I guess, at some point this type of practice is important, but what I found is that I wasn't getting much benefit outside of problems that looked exactly like this. So I wasn't achieving any transference for my kids. So, again, probably what I should have been doing is pushing my students into different contexts and making use of the fact that I just told them that the strategy is area and how we calculate that, and go into and have them really deliberate about a different context, and maybe this is an example of that. So our 4th takeaway is that you can have students solve problems in daily review, but we should keep in mind that recite, recall, apply really probably inhibits the effects of interleaving, because students aren't required to choose a strategy. So if we think a little bit more about that, interleaving is an effect that we probably want to make use of in mathematics. And if we consider that maybe daily review is not the best place to make use of that, then what is a structure that better serves the application of interleaving? And we think, and the work that we've been doing at Dawson Park and the dedicated teachers at Dawson Park have been doing is thinking about maybe interleaving is best applied in what we're calling a weekly or monthly review. So in that sense, we can interleave our basic facts in our daily review, and we can interleave problems in weekly and monthly review. But again, let's go a little bit deeper into what the evidence says about interleaving, so that we can get the best out of interleaving when we do implement a weekly or monthly review. So this is a really recent review of the literature from Chen, Pass and Sweller about interleaving, and looking at the literature and thinking about, what is the mechanism that leads to this interleaving effect? And what they're saying is this quote here: so interleaving assists learners to discriminate between similar concepts or topics of a domain. Let's have a little bit of a look at what they mean by that. So this is a classic study from Taylor and Rower. You might have seen this if you're at the DSF conference. Jana Weinstein spoke about this exact study, but just illustrates this point of similar topics or concepts of a domain, right? So in this study, there were 4 problem types that all look very similar on the surface level, but they're different. So this one in the top left is calculating bases, and the formula for that is base plus 2. So This is an octagon. So if we add 2 to that, that means that there are 10 faces on this shape. This one in the top right is edges, and the formula for that is base times 3. 8 times 3 is 24, so there's 24 edges on this shape. Corners in the bottom left here, obviously 16 corners, base times 2, and angles here. There must be 48 angles on this prism here. So those problems look similar on the surface level. And what they did was they studied the effect of interleaving with those problems. So you might call those problems A, B, C, and D. And they mixed the practice up like this. So they had a partial problem phase and then a full problem phase. But the practice was structured in a similar way for both. So the capital letters here, the worked examples that were provided. And then, so obviously in the interleaved condition, all of the worked examples were provided at the start. And then the questions were mixed up in little groups of 4. And then at the end, they had F for filler problems. And they wanted filler problems because they wanted to control for spacing. They wanted to make sure that the effects of interleaving weren't actually because of the fact that the practice was spaced. So in the blocked condition, they alternated between obviously the practice problems and the filler problems to provide for that spacing. And similar sort of setup for the full problem phase. What they found was that the blocked practice had perceived more success throughout the practice phases, but and the interleaved group appeared to be doing worse through the practice. But then when they tested the students the next day, they found that the students in the interleaved condition maintained their performance, whereas the students in the blocked condition fell away sharply. So this is an example of the effect of interleaving for concepts or skills that are similar at the surface level. If, for example, they interleaved problems like this, and this is not from the literature, this is an example we've generated. If they interleave problems like this, where they're not the same or not similar on the surface level, Chen-Pass and Sweller are saying that the interleaving effect, or they're saying that the literature says that the interleaving effect for this type of practice on the right would be reduced because they're not similar concepts or topics. They're not similar at the surface level. So this leads us to our next, our final takeaway here, that interleaving of problem solving requires students to choose and use a strategy, and the effect of that interleaving will be greater if we use problems that have a similar surface structure. All right, so there are takeaways. Let's have a look at how the guys at Dawson Park have been applying this evidence. So Rosenshine says in his paper that one example of making use of weekly and monthly review might be reviewing the previous week's content on every Monday, but every 4th Monday reviewing the previous month's content. So this is possibly an example timetable that could be implemented. The weekly and monthly review might take longer than a daily review, so we might dedicate a whole session to that and then have daily review plus our lessons for the remaining 3 days. Again, we should remember that the more practice students receive, the better their performance will be. So if you do have an opportunity to do a weekly or a monthly review structure more frequently than this, we would assume that would have a positive impact. So a couple of more points though to keep in mind when we're planning our weekly and monthly reviews. First, interleaving is about choosing and using a strategy, so we should vary the order of topics. And then also, if possible, we should use superficially similar problems when varying the order of those. So let's have a look at it, an example of what's been implemented in classrooms at Dawson Park. So maybe this is an example of weekly review, and maybe last week the teacher taught finding angles around a point, completing number patterns where there's an alternating rule, subtract 0.5, strat 0.1, strat 0.5, strat 0.1, and then maybe looking at interpreting these side-by-side column graphs. So thinking back to the fact that we want to mix up the order, but we also want to use similar surface problems if possible. So maybe in reviewing angles around the point, we also have them practice problems, other angle problems, like finding complementary or supplementary angles. And then maybe for finding the pattern, we also want them to practice problems that have the same rule in terms of, you know, increasing by the same number each time. Or maybe we also want them to work backwards from that as well, if that's a skill that we previously taught them. And then, you know, maybe for these bar graph type problems, we not only want them to be finding the total in two categories, we also want them to find the difference between two categories. So at Dawson Park, teachers would display this set of 8 or 6 or whatever number it is problems that are interleaved and give students an opportunity to practice those. They would monitor student performance as they're going around and make note of which questions students are being successful with and which ones they aren't. And then I guess if you're using student whiteboards or something, you can have a check at the end after they've completed these problems as well to determine what they've been successful with and what they haven't, because this weekly and monthly review doesn't end with just this set of 8 problems at Dawson Park. They do some far more effective things than just provide what is essentially a test. But, you know, tests are good. The testing effect has a positive impact on learning. So once they get a gauge of how successful students are being with each question, they then make a decision about what they're going to do next. So for each problem, there's a slide for teachers to debrief and provide a worked solution for students. So this, in effect, is feedback. And then what they do from there is, based on student performance, they can either, if the success rate was high, they can obviously model the answer to provide affirmative feedback, but then push students to higher levels of difficulty. So we might have another set of 3 prepared. And if students have been successful at this level of difficulty, then let's push them into higher level of difficulty. Let's extend them. And we're making that decision to extend based on formative assessment feedback that we just gathered from students. Maybe some of your kids were successful. So you push those kids, you tell those kids, no, you push higher. And the kids that weren't successful the first time, you give them another opportunity to practice. Essentially, you're modeling the correct answer, and then you're giving them an opportunity to implement that feedback immediately through another opportunity to practice, another opportunity to be successful, to apply that feedback that you've given, which is, we think, so important. It's far less effective to stop at the modeling stage or the reteaching phase and point out student errors without giving them an opportunity to implement those again. So I guess that's the other point here. If we've got a low success rate that's being achieved by students, then we model the correct answer and then give them another opportunity to practice. And maybe we have a simpler question as well, so that we can ensure success. Maybe we need to go back a step in difficulty. So this is a structure that has been implemented at Dawson Park that's we've interpreted to be closer to what Rosenshine termed a weekly and monthly review than a daily review. So before we move on, obviously, we've got an opportunity for teachers to remodel or reteach for every problem type. All right, so that is the little extensions of interleaving. So I hope that that little practical stuff and the summary of those most recent research findings has been helpful for you, and hopefully that you can start to apply that and have an impact on your students like the guys at Dawson Park are having. Jarred, are you awake,
I didn't interrupt you. I didn't interrupt you once. See that? That's called self-control.
Was there an opportunity to interrupt?
Oh, you made heaps of mistakes. It's all right. All right, my turn. Thanks for that, Jordan. I love listening to Jordan talk about education. He's so passionate about it. So look, I'm going to start exploring explicit lessons just briefly, specifically looking at work examples. There's a great chapter in Ollie's book about this. We highly recommend you read his stuff. We're huge fans of the work Ollie does in the education landscape. So we're going to look at explicit lessons with worked examples, but specifically what Dawson Park are doing with this, how they've interpreted it in their practice. So when it comes to explicit teaching, there's lots of different structures, different approaches for it that you can be familiar with depending on where you are in Australia or what your school's doing, their pedagogical choices. Now, we originally started off with John Fleming. We've been working with him for years. He's a great bloke. You've also got Archer and Hughes, and you've got Hollingsworth and Ybarra, the data work stuff there. This is all stuff that that we've worked with over time. And there's common similarities between it all. We're all kind of drinking from the same well here. So really, we're looking at these kind of common factors, our lesson design, lesson structuring. We have a review, we have some kind of introduction, and we have that familiar format of the I do, we do, you do, which, so many schools are using this. And what's funny is how there are different interpretations of it are, but it's all from the same kind of evidence base. Key to this for us is the we do. This is where the magic happens. Now, the main point of this is because there's so much guidance in it, that we do embedded within it, has so much guidance, so much back and forth between the teacher and students. This is where the biggest gains are occurring, and we're getting lots of that desirable difficulties that Jordan talked about, which is so important. It's this lift in cognitive effort that kids have to put into their work, and it makes the learning more memorable, more meaningful for them. The caveat there is that it has to be successful, which is where the guidance comes into it. You can't escape it. Even with the daily review and the weekly review, with all that retrieval practice, it's pivotal that you have that guided element to it, where the teacher is checking for understanding and correcting those errors at the point of error, right in the moment they're happening, live in real time. Good. Now, all of these elements of Rosenshine's principles should be happening in the we do. That's where you get the big bang for your buck. So that the guidance we talked about. We have the main point here, the guide student practice, the explicit structure to a T, which is breaking things into small, digestible pieces, managing the cognitive load that students go through, putting it in sequence for them, obtaining a high success rate, and knowing you're achieving a high success rate in the moment through that live checking for understanding. That's really what we're going for. That's what drives our lesson structure, drives our teaching, because we're getting that constant feedback from students. We've got provide models in there, asking questions, all this good stuff's happening, or it should be happening in the we do. Okay. Now, worked examples, like I said, we've heard that terminology before, and it's a bit of an easy idea at face value, right? It's a step-by-step demonstration of how to perform a task. It's a question broken down, but sometimes it gets left at this surface level for students, where it's just offered to them, and the guidance is pulled back a little bit, and that's a bit of an issue for us. Here's an example of something you'd see students see right now in their classrooms with the text they're using. Now, this is what a work example is supposed to be, right? No. Like we needed that to help us. Sorry. No, it's not. This is the issue. Work examples are a bit misunderstood. Maybe not by some of you guys who are deep in the research, but to the lay people, the people teaching, the parents at home. Like when I see my own kids bring this stuff home in their homework, there's a bit of a misunderstanding there. The worked example isn't about the actual problem being solved, having an example of a solved problem. It is the process of guiding student practice that gradually moves them to independence. It's that we do. It's that sticking in that pocket of learning, we sometimes call it, staying in the pocket with the kids and making sure they actually understand each component of the skill, each step to the skill, before you release them independent practice. It isn't about just giving them a solved problem or a set of solved problems and going, look, you can see it, can't you, kids, getting a thumbs up or something. That's not what it's about. It's about the guidance that you provide as an expert teacher, remembering that your students are novices. They don't have the content knowledge to be able to make expert decisions between things. We need to guide that process. And that's our role as an expert teacher. Look, these common examples, an introduction to your lesson, and I do, where you're modeling some examples and then you push into a you do. Students complete it. They watch you do it and then they have a go of doing it themselves. Another example over here of a more laid out way to. We have examples and the students going back and forth with the teacher, working through problems. Neither of these approaches include the type of kind of guiding of worked examples that we're talking to, or the literature refers to. It's not embedded within these practices here. What we're really looking for in this we do is the guidance. We want full-on the teacher to isolate that pocket of learning with the kids and back and forth with them, lots and lots of guidance in the we do. So we go to the research for this. What's some practices we can do that are validated by the research? Well, here's two big hitters for us. The first one's worked example problem pairs. This appears in the research, it's well validated. And the second one is faded worked examples. Let's have a closer look. So here's a really critical point. When we're talking about the I do, we do, you do, what we're really talking about is that we do is the I do, you do back and forth with the teacher. It isn't this idea of all the kids in the class are working on whiteboards together and just doing random stuff, like we're all busy working. It's a we do. That's not what we're looking for. We're looking for real guided practice. So the teacher is modeling something, they're going through an I do, they're pushing across the kids, they're doing you do, the teacher checks for understanding, it's back and forth, back and forth, back and forth. And it can last for as long as it needs to, until success is achieved. That's the whole goal of it, right? It's success driven. Okay, so let's look a little bit more closely at what faded worked examples are. You can see this set up on the slideshow right now. On the left here, it's just a breakdown of what the teacher and students are actually doing. So with faded work examples, the teacher's modeling it, all the steps maybe to begin with, and the students just copy that down. That's the first problem they're solving. It's all right, there's nothing wrong with that, because you're creating an environment in your room it's all about success driven. Students, you know, as many of you would know, that those of you that work with students out there directly, success is a huge motivator for them. There's really nothing else that motivates kids better than success. So to establish some success early on in the lesson, it's really an engagement tool. It brings all the kids to the party, because who doesn't want to be involved when they know the answers to things? Who doesn't want to be involved when they're getting praise from their teacher? Like, yeah, you got it right, Jordan. Good job. You know, that's a good feeling, especially if Jordan, you know, isn't used to that kind of praise or isn't used to succeeding at things, you know, which is, you know, very possible. So look, on the left here, we might start off by giving the kids everything. We're spoon feeding this content to them, but we're staying in this pocket. Remember, we're not speeding through it to release the kids to independent practice. They're not going to their books. We're keeping them in this pocket, and we're going to make sure they all have a clear understanding of the content. So on the left there, you can see for the next problem, the teacher might model 1 to 3 steps 1 to 3, and students copy and then complete step 4 on their own. We're just gradually feeding this and gradually releasing kids. And there's other ways to approach it here. This is just an example. The teacher can model less of the steps and slowly release the kids. But if you're getting a lot of success from it, you might release more steps to them and then still have the same number of practice problems together in the we do, but you're releasing them a bit faster based on the success they're having. Or as well, if they're not having a lot of success, you might slow down. You might reapproach the way you're teaching this content. Pull back and do more of the steps yourself and explain it more to students. This is just one example. The graph over here, yeah, illustrates that. It's showing the amount of teacher responsibility, and as you're moving through the we do, you're trying to release that, you're trying to push that across to students. And then finally, when you know for sure, for certain, that the kids are going to succeed with the content, that's the time for independent practice. And it really isn't that you do. It really isn't the most important feature of your teaching. It's more just the bit where they get to practice having some fun because they're succeeding with it, and you know they are. You haven't released them yet. So that's faded worked examples. That's one approach. It's a great way to teach. Here's another one, the worked example problem pairs. It's the same kind of thing. We're in the we do. We're in the pocket with the kids. It's back and forth. It's fully guided. But it's just another alternative to how you release that to kids. So in this one, the teacher might model and explain to begin with. The students complete a similar problem, and then it's straight back to the teacher. They model another example, and there can be variations here. This is one of the big things about teaching, is that there are so many variations to the skills. It's especially for the real complex stuff. There's things that the kids have struggle to push along to memory, things like fractions and metric conversions and all these kind of these problems. The issue with them is they're full of misconceptions. They're full of variations. And so as a teacher, our job and part of this process of we do is making sure that we expose students meaningfully to as many variations as possible, because once they've seen it and done it a bunch of times, it's no longer something that traps them. And that's what misconceptions do. They trap novice learners because it's just unfamiliar to them. They just don't have the experience with it yet. So the worked example problem pairs is just this back and forth between a teacher and student. And the teacher is getting so much opportunity to check for understanding during this time. At Dawson Park, in the teaching that Jordan and I do, it's full of whiteboards. It's full of that formative assessment. It's just constantly giving feedback to the teacher about whether they've got it or not. And in many cases, your instincts are wrong. You think, oh, this is easy for these guys. They're going to get it, and they surprise you with their answers. Or the converse can be true. So we really can't play a guessing game with it too much. We have to rely on the feedback we get from our formative assessment. So this is just another example of that, of staying in the pocket, that we do as the most important part of our skill guidance. Okay, there's more to it than that. So some research that's come out recently from Riddle and Johnson and others about self-explanation, that the power of having students generate their own explanations in an attempt to make sense of new information. It's a bit similar to other pieces of the research in cognitive science, elaborative justification or elaborative questioning, elaborative interrogation. There are so many ways to refer to it, but it's this process of having students try and explain their understanding, and then to make sense of the explanations of others, whether it's their peers, through pair sharing, or with their teacher, prompting these kind of conversations, this dialogue in class. This process of trying to make sense of that in working memory, this is powerful. It's a high cognitive difficulty, a lot of effort from kids they put into it. So we're achieving that desirable difficulties that Jordan was talking about before, which is all about the idea that they need to be some challenge to it. We know there needs to be challenge to it. It's an intuitive thing, but it has to be guided. It has to be based on success. So this is something we can add into our instructional time, having kids explain their answers, prompting them, trying to draw more out of them. And again, this is all happening in that pocket, in that we do. When you've got the kids right in front of you, explicit teaching, back and forth, this is a great time to use self-explanation. Okay, so some recommendations from that paper on how to approach self-explanation from the Riddle and Johnson paper. The first thing is we've got to remember this point again, that we, whether we like it or not, whether it feels comfortable or not, we as the teachers are the experts and the students are the novices. And as such, they just don't have the content knowledge, they don't have enough experience with it to generate the stuff for themselves. It needs to come from somewhere. So it's really important that we model it for them. It can be as simple as that, just modeling high quality responses, using the correct terminology, the correct language, approaching it properly. It's as simple as that, and you guys will do that all the time. Those of you that are teaching, and let's face it, we're all teachers in some respect, whether it's our own kids or whether it's our colleagues who aren't as sharp as they should be. We're engaging in this all the time. So it's so look, model things, demonstrate it, make it crystal clear for kids. It shouldn't be a mystery. Sometimes in teaching we get caught in this idea that we're giving the answers to the kids, but that's what teaching actually is. It's giving the answers to the kids and then giving them a chance to demonstrate their understanding to you. So one of the ways of doing this, at that first point at the top there, you can include explanation stems or frames. We've been doing these a lot. They appear a little bit in the next content in this slideshow, but the idea is that you're giving them high quality responses. You can set these out in a frame where the kids are just making choices. They're discussing and making choices about this. But the point is that you're giving them exemplars. They possess all the stuff they need to give good answers for you. So you're guiding this process, and it also makes them feel safer. What becomes apparent all the time with kids is that they just don't know that they're right. They actually have the right understanding and they're thinking in the right way, but they lack confidence. And so part of our job is to establish that safety, and by pointing out that they're right, by showing examples that allow them to see, oh yeah, I'm thinking in the right way. I'm on the right track. This keeps them engaged, it keeps them successful, and it allows you to maintain the momentum of your teaching, which is a really important thing for those of us who struggle for momentum sometimes. You don't want to lose that. You don't want to lose your kids once you've got them. So, look, come on, hurry up, Joe. The second point here is designing explanation prompts that using them selectively. We want to use this for our most critical content. It's the same thing with the elaborative justification, these elaborative questioning. It can take time. Even down to pair shares, these things take time to do. So we don't want to use them for things that are frivolous. We don't want to have the kids explaining content, what their favorite color is and why. We want to use it for our most critical points. And in that way, we it remains sacred. We're keeping it special, so it's not squandered. Now, these last points here, prompting learners to explain the correct information and highlighting misconceptions. Misconceptions are really they're the things that stump novice learners the most. And it's because often the idea of misconception is it's not intuitive. It's not something that's obvious to us. It's the opposite. So it's tricky. So connecting students with the misconceptions, connecting with why these are wrong, why they're tricking us, why they're tricky. This is really important. This is developing strong schema, the internal schema in students' minds. And the other thing is correct information. We often use frameworks for this, like formative quizzes, hinge point questioning, these kinds of things to illustrate this in concrete detail for kids. Here are the misconceptions. Here's your critical content. Connect it. Have students explain it. Have students work with it. And this is desirable difficulties. It's great for them, and it's building quality internal schema. Okay. So, I won't read this out to you. You can pause the video if you're that way inclined and have a little look at it. This is the idea of how you approach this prompting, how you're eliciting these responses from your kids, and then guiding the kind of class dialogue or guiding the understanding that's being formed around it. There's a script to it. It's helpful too, when you're starting out with this stuff, to build scripts. That's what, the distinction between explicit instruction and direct instruction. Direct instruction is this scripted stuff. There's room for that in our own practice all the time. Put a little script out, unburden our own working memory so we can be better teachers in the moment. Working memory isn't just for the students, it's for us too, So there's a little script to illustrate that, if that helps. This is the whole idea, we're committing the majority of our time when we're teaching to working through these problems with our students. That's what the we do is. I'm doing a bit, they're doing a bit, I'm doing a bit, we're releasing it to them. If they're failing at it, if they're not succeeding, we pull it back. This gradual release isn't one way. Like once you release them, you can get them back. And if you see in their answers that they're not understanding, if they're not building an accurate understanding, you need to. The onus is on us. We have an obligation to pull them back. So it's really important to consider. Here's another example. Moving from I do within the we do to then giving the kids a shot, the you do within the we do. It's really important this is back and forth and it's guided for. Look, another part of that research which was quite interesting, is this idea of incorrect worked examples. Now, the idea here is that we're actually connecting students to incorrect problems. We're connecting them to the misconceptions that are apparent in examples. So this is the mistakes that they're making, that they wouldn't be making if they weren't guided. And the point of this is that we're making that misconception concrete for the students. It's demystifying it. So instead of like, oh yeah, that strange problem you're talking about loosely with kids, abstractly, you actually want to show it to them. You want them to work with it and engage with it. Why is this a problem? What's the misconception here? What's happening here? Again, there's a cognitive effort to this, and because it's well supported and guided, it is desirable difficulties. Remembering that the caveat on desirable difficulties is it has to be successful. If it's not successful, it's not desirable. It's undesirable difficulties. So look, when we combine this, when we combine looking at incorrect examples full of misconceptions, and we're pairing that up with self-explanations and having kids elaborate, we're prompting these really high quality responses from them. We're really establishing powerful learning. Like you look at you imagine what internally what's happening to them as they're building up this schema, internal schema, this kind of like library of all the variations that you practiced, all the good things that you did, all the ways they're going to see this in the different contexts. And also that's directly connected to all the misconceptions, all the things that throw other learners off that they're no longer going to be suffering with because you've done your due diligence with teaching them. So yeah, this is a good partnership. So here's an example of having a problem pop up and making kids engage with it and think about it. Now, this could be paired also with pair shares. You could have partners discussing, groups talking about this together. And again, as long as it goes back to the teacher's sampling answers from them and getting their responses and working with those, making sure they're correct, making sure kids are developing a correct understanding of the content, then it's just gold. So imagine this as a question like this, a slide coming up during your instruction like this. It's very similar to the Dylan Williams hinge point questions, formative assessment quizzes. And it's putting it up as a visual and having kids work with it, trying to figure out what's going on here. And then this again is guided in the we do. It's not put out as an afterthought. It's not an exit ticket as such. It is something that we're processing together as a class and make sure everyone understands what's going on here. And so this would be done on whiteboards. Whiteboards are one of our favorite tools. Anyone out there right now who's teaching without them, I don't know what you're doing, because it's so hard to check for understanding across a whole class of kids. 30 kids, to get responses from them in a way that is quick, that you can quickly assess it and give feedback. And that's what the beauty of questions like this are. We're not having kids write long sentences out on whiteboards. We're not going through and sampling each kid one at a time and having some kind of conversation with them. You're getting a fast response from all the students in your class, A, B, C, D, and that's prompting the conversation that you then have afterwards. It gives you fuel for your decision you're making as a teacher. Can I move on? Or do I need to stop and go through this? And, you will. Most of the time you'll have to stop and clarify and maybe elaborate if necessary. And if kids aren't succeeding with it, you might have to stop altogether and do another example and have another question come up and really spend some time with that content, because you cannot move ahead if students don't understand it. It's too risky, because when they get further ahead in the learning and then everything falls apart because you missed this little check, the consequences can be detrimental. They're serious things. It isn't that the student got the question wrong, it's that they then think they're an idiot, or they think they're never good at maths. Like, oh no, I got the fraction question wrong. I don't know fractions. I got the BIMDAS question wrong. I don't know BIMDAS. I'm useless. I'm stupid. That might seem like a silly thing, like a minor thing, but it's really not. A lot of Jordan and I's teaching revolves around trying to undo that attitude that kids have about themselves, and one of the great things at Dawson Park that we're so proud about is that those kids there, they have this self-belief that is quite amazing. And for those of you who visited, you would have seen it too. It's not unusual for those kids to have self-belief in other areas, playing computer games or playing footy. But for them to know that the content they have in class is difficult, it's challenging, and they're going to conquer it. And when they don't conquer it, their teacher's going to help them conquer it. It's success or success. Like, in the end, they're all succeeding. That's the goal. Building kids up to feel good about themselves. That's that. That brings us to the end. I'm sure Jordan has something really powerful, potent to end us on. But before he does, I just want to say a big thank you to LDA for having us on, and for you guys, for those of you left watching who haven't switched off already to go and do more important stuff. Really appreciate it. We are just teachers. It feels a bit strange to be amongst such juggernauts in education when you look at the other people that have spoken on the WWWs. So yeah, we're very humble and appreciative. So thanks a lot. Jordan.
Thanks, guys.